All right, we're going to continue our discussion of exponent rules, moving on to the division rule. So here we've got x to the sixth divided by x to the second. So what this actually means, if you expand it out, is x to the sixth would be x times x times x times x times x times x 6 times. And then in the denominator I have x squared, or x to the second. So that just becomes x times x. And so remember, the rule with fractions or division is if you have something divided by itself, you can cancel it out and basically make it 1. Like 5 divided by 5 is 1, 8 divided by 8 is 1, or x divided by x is 1. So since there's two x's on the bottom, you can match up each of those x's with one from the top and cancel them out. Okay, so what that leaves us with is we cancel out 2 x's from the top and 2 x's from the bottom, so all we're left with is 4 x's on the top, or we're left with x to the fourth. Okay, and so that would be my simplified answer. Now the shortcut for this, the division rule, is if you have two things with the same base in the numerator and denominator, you can simply subtract the exponent. So like x to the sixth over x to the second can be thought of as x to the 6 minus 2, and 6 minus 2 is of course x to the fourth, which is what we got. Okay, another good way to remember this is the division rule is basically opposite the multiplication rule. So in the multiplication rule above, we added the exponents. For the division rule, we subtract the exponents. Okay, so over here I have another example. It's a little more complicated because I've got several different variables and some numbers here, so we're just going to simplify this one step at a time. We'll start with the numbers. So I've got 12 and a 3 as the coefficients. Okay, now these are not exponents; they're just regular coefficients. So I don't subtract them. I'm just going to divide like normal. So 12 divided by 3 is going to leave me with 4 in the numerator. Okay, I've got an x on the top and an x squared on the bottom. All right, now I can cancel out one of the x's. But the leftover x is left over in the bottom because I canceled the x out of the top, and then I canceled one of these x's out, but there's still an x to the first left in the bottom. So there's an x left, but it goes in the denominator. Okay. As far as the z's go, there's a z to the first on top, a z to the first on the bottom. So since it's exactly the same, those are going to cancel out completely, and I don't need to put any z's in the answer because it just becomes 1. All right, then if you look at the y's, I got y to the fourth on top and y to the second on the bottom, so I can cancel out 2 of the y's. So all the y's are gone from the bottom, the y's on the top. 4 minus 2 is 2, so I've got 4y to the second over x as my final answer. Okay, so just be careful with these if there's some left over, whether they're left over on the top or the bottom when you do this. Okay. All right, next we have the zero rule, which is actually a pretty easy rule. So you have x to the 0. Now your instinct might be, when you first learn this, and you might have forgotten, but your instinct might be that x to the 0 should be 0, but it is not 0. Anything to the 0 power, anything and everything to the 0 power is 1. So x to the 0 is 1. And that's true for everything. So like if you saw 5 to the 0, 5 to the 0 would be 1. If you saw a million to the 0, a million to the 0 would be 1. Over here, see how I have this whole complicated expression? It's actually the same expression I had up here. If you take this entire expression and take it to the 0 power, the entire thing simply becomes 1. Okay? Now, if you're curious why it becomes 1, think of it like this. Think if we had, say, x to the 5th over x to the 5th. Okay? Now, you should know that x to the 5th over x to the 5th, it's something divided by itself, so that is equal to 1. We know that. But if you think of this in terms of applying the division rule where you subtract the exponents, x to the fifth over x to the fifth could be thought of as x to the 5 minus 5, which is x to the 0, and that's why anything to the 0 power is 1, because all the exponents are gone, and so you have nothing left